Preparing your data for your analysis can be the most time-consuming portion of any GIS project. There are several different tools and methods you can use to actually prepare your data, but in this module, we are focusing on some of the basics. So let's start with our most basic form of spatial analysis, asking our data a question. By now, we've used a lot of selection tools in a lot of our lab exercises, so we'll focus a lot more on our queries in this module. With either queries or selections, remember, we're not necessarily creating any new data, we're just simply trying to find out more about our data. There are two main types of queries that we'll focus on in this module. First, we can ask a question about data stored on our attribute table. This is creatively called an attribute query. So let's say you had a set of data that contained California agricultural production by county. So it's a shapefile, I should say. We can use an attribute query to find something out like how many counties harvest over 1,000 acres of artichokes in 2012. Or what counties produced over $2 billion in agricultural products in 2019. These were all questions that could be answered on an attribute query. It's likely that we would have a field in our attribute table that has to do with artichoke production, or the land used to harvest artichokes, or the dollar amount of agricultural commodities produced. So that's our attribute query. The other type of question we can ask our data is about where it's located in space or where it's located relative to other things or other features. This, again, creatively, is called a location query or a spatial query. So let's go back to that agricultural product data set again. So it's our shapefile. So we could ask it questions like, where are dairy feedlots within a mile of irrigation canals or waterways, if we had a shapefile that was waterways in California? Or how many almond orchards fall within a 100-year floodplain? So again, we could pull that 100-year floodplain data and see where the two are in the same location. Or maybe, are there any farms within 5 miles of an elementary school? Maybe you want to do some outreach or get kids more interested in farming. These queries will highlight on the map, again, where those features maybe overlap or share the same space. So with both spatial and attribute queries, you're not creating any new data, you're not making any changes to your data, you're not doing anything, you're just asking it those simple questions. Another way we can prepare our data for analysis is using joins and relates. So in this part of the module, we'll look at different ways we can work with tables. And there's a lot of details in how you work with tables, but let's sort of back up and consider this situation. And it's a pretty common one. Let's say you have a Excel table, so a non-spatial table that has two fields. It lists two columns. It lists California counties and population of those counties. How do you link the two? Or how do you link that to a shapefile of counties? So let's say we've got that attribute, non-spatial attribute table, and our feature class or shapefile of California counties. How do we link the two so we can display on a map, on a choropleth map, the total population of each county? In this example, we could use a join. This would allow us to append the population attributes to our shapefile of the California counties, and then we could go about symbolizing the data. But what if you had this situation? What if you had your same California county shapefile, but your non-spatial table is a table that lists all the farms in each county? So each county will have multiple farms listed. In this example, you would use a relate. Unlike when we join tables, relating tables is simply developing a relationship between your non-spatial table of names of farms in each county and your spatial data. So there's no appending of the attribute. You can't really use it to display in a choropleth map or anything like that. But you can see that related data. So you could do some queries about that data or get to know it more that way. But what if you did want to know how many farms were in each county? Let's say it's not tabular data. Let's say you have a point feature class that lists all of the farms in California, or all of the, what's my other example? I guess I just said farms. All of the artichoke farms or almond farms, orchards, whatever you're looking at. So you have a point feature class that just shows where they're located, and you want to count how many artichoke farms are in each county in California. That's where we can use a tool called Spatial Join. Now, all of these examples related to joins and relates, there are a lot more details in your lecture, and I have a couple other videos in this module that go into details about joins and queries. So take a look at those if you want more information or more clarifications. It's just your broad overview. The exercises in this model are going to give you that hands-on time with the GIS software to explore some of these topics, test them out, and see if they're right for your final project. You will probably have to do one of these analyses on your final project. So take some time and really think about what we're looking at and how a query or a join may benefit your final project or your data set.